Tonight, we'll hear from even more alumni working in the farming, sustainability, and food sectors as they continue to discuss new technologies in agriculture, how they got involved in the space, challenges facing the industry, and what we and you can do about it. They'll explore topics like regenerative agriculture and soil health, climate change, and improving our food system. So my thanks to a terrific panel tonight. First, we have Brennan Clark McFeeters. As we were planning the first session and tonight, there was a resounding call by our alumni to not go any further until we get Brennan Clark, because they are out there doing this. They're farming every day, all day. And we have scheduled this for mid-November so that we could let them do their harvest. So really excited to introduce Brennan Clark McFeeters, class of 09, right? 09? Yes, okay, great. Brennan Clark operate a 7,000 acre farm in Gothenburg, Nebraska, where Clark grew up and his family has farmed for 6 generations. They produce food grade corn used in tortilla chips, as well as soybeans and alfalfa for livestock feed, alongside several thousand acres of native prairie grass that they lease for cattle production. Since returning to the farm in 2011, they've used their engineering backgrounds to solve problems and improve efficiency of the farming operation, using technology such as satellite and drone imagery, strip till and no-till farming systems, georeferenced variable rate application of seed and fertilizers based on soil sampling and production history, and center pivot irrigation systems with telemetry and moisture sensing soil probes that I'm sure they will say much better than I did. They believe that an important part of farming is being good stewards of all their resources: land, water, air, seed, fertilizer, labor, and capital. Our next panelist is Tiana Veldwich, class of 08. As Director of Product Management at Indigo Ag here in Boston, Tiana helps farmers get compensated for sustainable agriculture practices through grain premiums and carbon credits. She's currently focused on tools to support farmers in pulling together the data about their farm into Indigo's system to reduce the farmers' efforts to participate in such programs. And finally, Mariko Thorbeck, class of 16, is a sustainability consultant, where Mariko helps large food and ag companies understand the role of regenerative agriculture in meeting their carbon reduction and net zero goals. She's currently focused on the development of climate roadmaps to support the alignment of agriculture with global climate goals and initiatives. Mariko and her husband, Chris, and baby Yoshi, beautiful baby Yoshi, who was giving Mariko a little bit of a hard time tonight, have a 2-acre homestead raising goats, chickens, ducks, fruits, and vegetables. And here to moderate the conversation and to talk a little bit about what he does is Jake Felser, who works locally at Freight Farms. In his role as CTO at Freight Farms, Jake leads the technology development efforts across both hardware and software teams. Before Freight Farms, Jake was VP of Engineering at EATSA, where he led the development of groundbreaking robotic food assembly and delivery systems. Jake has previous experience in a variety of engineering and leadership roles, and has developed and launched products across several categories: consumer, IFT, sports tech, industrial, energy, and medical. Again, welcome everyone. And Jake, I will let you take it from here. Thank you.
Thank you, Sally. Appreciate the intro. So I guess, I think it'd also be nice to kind of start off and just go around the panelists and talk a little bit about kind of how we got into ag, what we're working on, a little bit maybe deeper than the description, and in our own words, and how we got there from Olin, which I think is pretty varied across this group. So I don't have a mic to hand off, but Brennan Clark, do you guys want to kick off?
Sure. Well, it's a pretty simple story for me. I was born into agriculture, so it wasn't hard to get back into it after I got done at Olin. My family's farmed in the same area for generations, and it was something that was always on my mind, no matter where I was, et cetera, that I might want to come back and be a part of the family farm. So, and I brought Bryn with me, so she can tell a little bit about it.
Sure. I'm class of '09 and I studied engineering material science. And I had a bit of a thread of agriculture through my whole life. My grandpa had antique tractors and I grew up going to tractor pulls and things. And I also interned with Case New Holland, the agricultural equipment company. And then Brennan Clark, we worked as at an electrochemical R&D company for a few years and then decided to go try farming. And it was very appealing for how technology driven it is.
Yeah, I think that's something that I really want to get into in a little bit, is kind of how you apply your own education to what you do every day. Tiana, do you want to go next?
Sure. Thanks, Jake. So Tiana, I did bioengineering concentration at Olin and was in the healthcare space doing product management or product adjacent stuff for my career up until I joined Indigo, got an MBA along the way. But I was in the healthcare space and really getting an itch to do something in sustainability and be addressing climate change through my day job, not just, hobby on the side. So when I found Indigo, it seemed like a great opportunity to be able to apply software product management skills to a particular area of the climate solution. So I joined Indigo about 2.5 years ago, expecting to work in person in the Boston office, and have been working from home since. But.
And is that a ton of CO2 gas or liquid CO2, or what's the
Yeah, so we made this promotional inflatable ball. Recently we received our first set of carbon credits, and it really helps show the scale. If I get out of the way, you can see there's a large piece of farm equipment in the background. But the CO2 gas for a metric ton's worth is that size. So trying to show the scale of what you can be reducing on your way to making a carbon credit.
It's very cool. And Mariko, what brings you to this conversation?
Yeah. Hey everyone, I'm class of 2016. Food and sustainability were almost always my two passion areas. I did a concentration in environmental engineering when I was at Olin. And at some point, climate change kind of became one of the forerunning issues related to food and sustainability, at least what was getting a lot of attention from corporations. And then it turned out there was a pretty big need for people with engineering backgrounds to be doing a lot of the greenhouse gas modeling and quantification and inventories for farming, for agriculture. And so that's kind of how I got into this space. And after working with different consultancies for 7 years, I finally decided that I was ready to not have a boss anymore. So now I'm working as an independent consultant, and just had a baby 4 months ago. So technically still on maternity leave.
Well, thank you for joining us from maternity. So as kind of a first question here, Brennan Clark, I think, what Sally said was exactly right. Like when we started planning this panel, there was a lot of talking about sort of these more abstracts, like tech companies that people were working at. And at the end of the day, everyone said, wow, we really need to talk to farmers. And there aren't that many Oliners who are farmers. And you guys are awesome for being on this panel and agreeing to do this. And I want to just dive right in and let's talk about it. So maybe you could tell us a little bit about your farm, and let's go right into soil. Kind of, how do you think about soil? How do you manage soil? How do you think about sustainability on your farm?
Sure. So I'd say Sally kind of gave the intro there. Our big industry really is growing food grade corn, and so a little bit different than good old number 2 yellow corn that might go into cattle production or into an ethanol plant, we have a lot more stringent requirements, obviously, because it goes into a food grade product, goes into tortilla chips. And as far as soil goes, you know, my family has farmed some of the same land for over 100 years. So we have a vested interest in maintaining, you know, the structure and the properties of the soil in a manner that's conducive to growing crops, you know, growing high yields. So we tend to think about soil health, or traditionally we thought about soil health almost more in a chemical fashion. So we could measure the properties of the soil, right? Things like what its nutrient content is, and you know, what kind of holding capacity it has for cations. A lot of fertilizers are in cation form once they enter the soil, and even some things like organic matter. That's something that we watch. We're trying to build more organic matter in our soil. Organic matter is what supports microbes to be able to feed the crops that we're growing, and also be able to hold the nutrients that we're applying. So kind of really from a chemicals perspective, historically, I think in the last few years, farming's gotten a lot more focused on soil health. And of course, everyone it's a little bit like saying the word sustainability. There are a lot of different definitions of sustainability. So there's a lot of different definitions of what soil health is. You could look at things like infiltration rates. If you're trying to increase your ability to absorb rainfall, for example, you could look at, you know, soil carbon. So you might reduce tillage in order to store more carbon, gain some carbon credits, for example. Or even just there's a few tests out there that are even looking at the DNA of the soil microorganisms. So do you have soybean cyst nematode, for example, that's a problem in soybeans, or, you know, any other kind of microbe that might be either beneficial or non-beneficial for your crop. So that's kind of where things are heading, right? We're trying to manage the best we can, kind of really the chemical properties, and then also the living components of the soil. You know, soil's about a third air, a third water, and a third other things, you know, minerals, organic matter, etc., solids. So, you know, if you have too little air, right, you have compaction. So we try to break up compaction using tillage, or using something like a tillage radish. Those kind of things can be used, or a winter rye, things like that. So it's really about, you know, managing the soil to suit crop production, and not have runoff, keep nutrients where they're supposed to be, keep the fine particles in the soil from eroding from wind and water. So we try to manage all those things at once, which is a trick.
Can you give just a sense of scale for what you're doing? Like, I know Sally said 7,000 acres, which is a large number. What does that like really mean?
Sure. So an acre is about the size of a football field. And so you can imagine, you know, 7,000 football fields put together. About half of that is either row crops or alfalfa. The other half is like native grassland. So it's pretty hilly, not really suitable for, you wouldn't call it arable probably. You know, it's too much slope and too little rainfall without irrigation to be suitable for row crops especially. So we lease it out to graze. We used to run our own cow herd, but you know, there's some good things about being diversified, right? Having multiple enterprises on your farm, and there's some things that are not as desirable. Like sometimes the activities need to all be done at the same time. Like cattle need to get to pasture at the same time you're trying to complete all your spring field work, you know, things like that. So we kind of made this strategic decision, I think 30 years ago this year, to just go into plant really, you know, row crop agriculture and not run our own commercial cow herd anymore. So I have lots of people around me that do that. We lease to a guy who runs a cow calf herd on grass on our native grassland, and so yeah, it kind of gives you a little bit of sense. So so it's hard to get an idea of scale we have big machines, I guess. You know, we have a crop sprayer that's 120 feet wide. We're actually converting to a different planter that's 80 feet wide. We have some other implements that are 40 feet wide. We harvest corn at 40-foot width and soybeans at 45-foot width. So pretty, you know, really optimized for one operator to be able to cover a lot of ground in a short amount of time. Farming is very mechanized, a lot of technology that enables us to, you know, get the best productivity we can out of all our resources, right? So
Another thing to add for the soil health is the grid sampling. Sally mentioned at the beginning, we're able to create variable rate maps to optimize our input application. And for compaction, they've also switched to tractors to reduce the compaction. They do lots of different measures to take care of the ground itself.
yeah, so that's kind of really the way ag is headed, right? To have less footprint. Sometimes that requires more footprint in the case of a track, you know, more spread it over more area, but you know, have less footprint in terms of like we put on basically the same amount of nitrogen that we put on 20 years ago, but we're growing more bushels of grain on that same unit of nitrogen, for example. Just higher productivity hybrids, better methods. So just trying to I compare it a lot of times to a manufacturing plant, right? You want to have the lowest cost per unit and the most output. And what's our best way to do that? And of course, take care of our plant, right? Take care of the soils we're producing crops on.
We're also always watching for new technology, perhaps new tires for our equipment or pivots, and also like the pivot biotechnology as well.
Yeah, and those who listened to the last panel, Elle, who was on the last panel, I believe, you guys are a customer, right? So.
Correct. Yes, we use Pivot Bio, proven on all of our corn acres. So that displaces some synthetic nitrogen. About roughly the credit I typically assign to it, that they have a new product out that's supposed to supply 40 pounds of nitrogen, and a typical application amount throughout the season for us would probably be somewhere in the 200-pound range for nitrogen, might be above or below depending on the yield goal for the field. So it displaces around 10% of our synthetic nitrogen to use Pivot Bio, and it also adds some predictability where if we have a really rainy season, the microbe is going to stay on the roots of the crop. It's not going to leach down through the soil like an application of nitrogen might. So that enables us to be better stewards again, and of course, less carbon footprint, not having to apply nitrogen. It's something that I can get done in the same pass it goes in the fertilizer that we put on with the planter. So we're not adding any additional passes in the field to apply it. It's just something we can do as we're going, and it works well in a lot of our soils that are. We farm some pretty sandy soils that don't hold nutrients as well as some of the darker, richer soils. So that's a way we can combat losses of nitrogen due to rain, especially.
So Tiana, switching gears slightly. So carbon markets, right? We're talking about soil and what's in the soil. What is you and Indigo doing about this, right? How do you generate carbon credits and how do you help farmers?
Sure, thanks. So the basic premise is a carbon credit is a way to have someone who wants to offset the damage that they're doing, whether it's a bank, an airline, a food producer, like a food brand. If they want to reduce their impact, but they're not going to go out and plant a bunch of trees, for instance, they can buy carbon credits that go to compensate the farmers like Brennan Clark here for doing new additional practices that they wouldn't have done were it not for getting paid for this, but that are a change in how they're farming So it is a, sort of a net new thing that that they're doing in their operation. And they can do a few different things that sort of qualify in either reducing their emissions, so having less, less passes by the tractor, with fuel usage, or having more carbon just trapped into the soil through the natural processes of photosynthesis. If you let that carbon stay in the soil rather than tilling it up each season, those are some of the ways that that specifically agricultural land can generate carbon credits, as opposed to a forestry project where someone might pay you to either plant some trees or protect some trees you'd otherwise cut down. So what Indigo is doing really is making that transaction possible, because Clark can't really go up to BCG and say, hey, BCG, give me $1,000 and I'll stop tilling my field quite so much. That's just not an individual transaction that most farmers can get into. So by doing this as a group, we can do it in a way that's more scalable and allows us to take advantage of some modeling and sort of data analysis practices to do it in a way that we can base the change in the farmers soil carbon content based on mostly data that they're providing, rather than having to go and take a physical sample and test it in the lab of every single acre of farmland, because that would get very expensive very quickly. So by doing this as sort of in aggregate, we're helping the farmers to have access to that opportunity to sort of participate in the carbon market, and we're helping the brands and companies that want to do that to have a way that they can pay for agriculture or climate damage in a way that in many cases they like that it is maybe in their supply chain, right? They use some agricultural products, so it's nice to keep that benefit within their sort of overall footprint, and it's part of the local economy and helping farmers. It's a nice benefit versus we'll go plant some trees. Nothing against trees, sorry, I don't mean to be hating on trees tonight.
Not at all. And I want to come back. So we're going to come back very shortly to the challenges on the ground with carbon credits. But before we go there, I want to go to Mariko quick and talk about if you can just comment on sort of what the customer side of this looks like. Like, who are the brands who are buying carbon credits? Why are they buying them? And do they know what they're signing up for?
Yeah, so this is one of the very interesting things is a lot of the companies that I'm working for. So these are global food and ag giants, companies like General Mills, companies like Cargill. They are making public commitments to basically limit warming to 1.5 C. So anytime you see a company say we're committing to net zero by 2050, they're basically committing to limiting global warming to 1.5 degrees. Under these goals, there's typically a short-term component, which is typically a reduction only component. So a lot of these companies will say we're committing to reducing our corporate emissions, 30% by say 2030, and then reaching net zero by 2050. Where the sort of offsets come into play is a lot of times companies in their reduction goals, based on kind of the methodologies and the standards, may not be able to apply offsets because they need to prioritize on first actually reducing, say, the amount of fuel that they're using, the amount of fertilizer, et cetera. But once we get to sort of 2050, that's where companies that still have sort of residual emissions that they weren't able to bring down are likely going to be purchasing these offsets. But as Tiana, I'm sure, knows very well, there's still quite a few complications in all of these transactions and how the accounting is working. So ultimately, companies are really looking towards these sort of global standards that are currently being developed as to when they're able to offset, when they're not able to offset, and what sort of claims they can make to avoid, say, greenwashing accusations when purchasing those credits. So it's a lot more complicated than I can explain in 30 seconds, but there's a lot happening right now in this space that a lot of us are trying to navigate.
So yeah, let's dive into the other side of the complexity because it's totally complicated on both sides. Brennan Clark, maybe you guys can comment on what this means for you on the ground as farmers, because it's way more complicated than just, oh, don't till this year, right?
Sure. Yeah, I'd say, it's something we continue to work on because it requires a lot of record keeping. It's not something that you just do one year and then it's kind of self-sustaining. I think the first year record keeping is the hardest, probably. A lot of times you have to prove some historical practices or a change in practices. And we're kind of just getting started on that on our farm. We actually are applied for some carbon credits based on this year for the first time based on our use of the Pivot Bio product. So since we're using a microbe to produce some nitrogen instead of using synthetic fertilizers, there's a carbon offset to that. So I'm interested to see how that goes. I think the other tricky part about the carbon markets is everyone's still kind of figuring out what the credits are worth. And Tiana can probably talk a little bit about that. I think, companies often will make a commitment that they will give you so much per credit minimum. And then, there might be a market beyond that, just depending on, what the supply and demand balance is in the market, right? And so those are some of the challenges. So changing practices in some cases is, fairly shows a clear impact on ROI on the farm. Like we, for example, changed from ridge till because we were furrow irrigated to just a flat plant, so strip till or no till system. And really what enabled that was center pivot irrigation. So sometimes it's the purchase of another technology, right, that enables it. Had to purchase a strip till machine, for example. I think I'm on about my fourth one by now. So, it's one of those things where equipment wears out, you replace it. In the end, the ROI has to be there to make it be a wise business decision, for our farm. Because one of our limited resources is capital, right? And so in order to be environmentally sustainable, we can't do that at the expense of economic sustainability. So some other practice changes that we've considered on our farm, we're always just constantly in evaluation mode, right? You can even go watch what your neighbors are doing. It's a little different than a manufacturing plant where, if you wanted to take a look at Samsung's semiconductor fab, they probably wouldn't let you in there. But farming is a little bit different because I can drive by on the road and see what my neighbors are doing frequently. And so sometimes what they're doing is I want to emulate that, right? It looks good. I can tell that things are going well. Sometimes not as much, as people try some experimental methods. I feel like cover crops are still a little bit in that area where we haven't quite mastered them yet. Everyone's really excited about them, but the trick is not having them impact your primary crop. So there can be, like, for example, just this year, I had a neighbor who planted cover crops, and then we had a freeze on May 18th, and it took about a third of the stand of corn that he had there, made it really blotchy and patchy. So, cooling the soil isn't necessarily desirable. Usually in our climate, we're trying to warm up the soil in the spring. So that's just one example of when you make a change to a system, you push the needle one way. Sometimes there's either desirable or undesirable effects. So a desirable effect of cover crops might be that you really needed a grazing crop for your livestock in early spring, for example, and the cover crop was already planted in the fall. It's already green. It's easy to get it, up and going in the spring. You can even apply water to it if you have a pivot to get more grazing. So you just always have to take it from a risk benefit analysis perspective. Any practice change that we make.
Yeah, oh, go ahead.
There's also the challenge of manpower and inputting data and it is a challenge to find good help. And Clark has 33 years of experience, and he's
There you go.
35. So
Yeah.
it's really beneficial, that farming experience, and it's hard to come by. So that's another challenge that we have. So I'm really glad intelligent people are working on systems that can help us do that. So thanks, Tiana and Mariko.
Yeah. To sort of comment on some of what Clark was saying, the price of a carbon credit and like the actual market that is taking place is rapidly evolving. So the price that we were able to sell carbon credits to buyers has increased quite a bit in the past 2 years since we've been trying to generate and sell carbon credits. But the different companies that are doing it have different business models and different ways that they're approaching it. So like we guarantee that the farmer gets 75% of whatever we're selling from their farms. So like if you earned 100 credits and we sell them for X dollars, you get 75% of whatever that was, and then do that across all of the farmers. But it's, as you're looking at that, as Clark and Brennan are business people, they are running an operation. So, looking at the cost of the changes, whether it's having to buy different equipment or buying cover crop seeds, or just the risk of making that change, that's being weighed against the potential benefit. And in some cases, there could be positive benefits just of this, for the soil health, in addition to the carbon credits. But as that carbon credit price is growing, that equation is changing. So I think there are a lot of folks sort of sitting on the edge of the pool waiting to see where it's going and whether it's worth jumping in yet. So I think that's part of the spot we're in.
Tiana, can you comment a little bit on the concept of having to change something to get the credit? Because, if I've been doing something really well for a long time, it feels like I'm getting shut out, right? How's that fair?
Yeah, well, so that's a big part of the carbon credit piece is, Microsoft doesn't want to pay you just to keep doing a thing because you have been doing that, and chances are you're just going to keep doing that. That doesn't actually, you keeping doing the good thing doesn't actually make any difference, doesn't offset the damage Microsoft is doing by, running its server plants. So they only get the benefit if you are making a difference in your practice, if you're doing something different because of the money that you're putting into this. So that, and that concept in carbon credits is called additionality. So you need to, and Clark touched on this, of needing to show history in your data. So in our case, we ask for 3 to 5 years of history to see, I tilled this much, I tilled this much, I tilled this much, now I till less. Well, that's the part that difference is what you're actually getting credits for. Mariko, I see you want to jump in.
Yeah, no, these are questions we get all the time. And I think that the thing I like to remind people is that ultimately these sort of carbon credits, they're really a construct. And so in some ways, in order to generate credits, we have to basically we have to pick an arbitrary point in time to be a baseline. Now, that baseline, however, in the grand scheme of things, is typically representing a very recent state rather than a historic state. And so in some ways, what I've heard some people argue is that, for example, in the US, a lot of times the recent state of carbon in the soil is actually coming from a pretty degraded state where, historically that land would have probably had a lot more carbon, but due to certain agricultural practices, that carbon could have been lost. And so this is potentially one of the arguments I hear against carbon credits is that oftentimes when farmers are changing practices, what they're really doing is they're putting carbon back in the soil that was actually lost from that land over the last several decades. And so in some ways it could be a little bit dubious to try and sell that carbon to companies to try and offset those companies' emissions. But this is kind of like a big part of the conversation right now, is because we ultimately do need that carbon to come back into the soil. The question is, how do we incentivize that? And at least from a corporate reporting methodology standpoint, when can companies take credit for participating in the incentivization of sort of those practice changes that might lead to increased soil carbon sequestration?
So
The other thing I'll jump in on, Jake, is we do also have a market for just grain buyers to just pay extra for sustainably grown grain. So that's sort of the other side of that, is if you have been doing those really excellent practices all along, you may not be eligible for carbon credits, but you could be eligible to just get 30 cents a bushel more for your corn, because there are brands that are looking to make other sustainability claims, even if it's not the reduction specific to carbon credits. They're just looking to be able to say, this corn was grown with less water, or this corn was grown with less fertilizer. They're still buyers of those crops that are willing to pay more for the sustainably grown. So that's sort of one of the balances we've struck, is being able to, for those folks who are already doing, and it's a little tongue in cheek, but all the right things, because there are always more things you can do, but you can at least get paid a premium for grain that is produced in that way.
And I think Christy talked about this a lot on the last panel, just like the market for kind of what will people pay for, like, okay, these corn chips are made with sustainable corn, for instance. Brennan Clark, so you guys, just in talking over the last few weeks, you guys don't think in timescales of 3 years, really, right? You think much longer than that. So I'm curious kind of how you see that in terms of your soil stewardship and relative to like changing a practice over 1 year or 5 years. Just how do you think about that?
Sure, that's a good question. So I would say you're right. We do think in longer timescales. In agriculture, you only get so many shots, right? Our production cycle is a year long. And so, in a standard length career, you might have 40 years. If you're like a lot of old farmers, you might have been farming for 50 years, but or 60. But that's always tricky to make changes, right? Because, and I actually, my brother posed this question one time. He said, "You're changing so many things in 1 year. How are you going to know what made the difference?" I said, "I won't." It's kind of one of those things you almost through. Sometimes it's kind of a hunch or a gut feeling. It's a hypothesis that you're testing, and you're right. Sometimes you don't know what the outcome is for several years, what the impact is. So that, and one way you can get more years of data, right, or more years of experience, is to compare notes with other farmers. There are organizations dedicated to that, that help us benchmark, help us compare notes. So that helps. It is an interesting time scale to work in. Sometimes it's minute by minute, and sometimes it is when we hire a new employee, for example, I really don't feel like they're fully trained for at least a year, because we might only plant for 2 weeks out of the year, and then we might harvest for 4 to 6 weeks out of the year. And then there's lots of other activities that happen in between that might happen once during the year and then never again until next year. So we only hook the planter up once, right? The hydraulic hoses go in the outlets here. So you have to have somebody that really has a good memory, right? To keep track of all those things. And so, yeah, as far as changing practices, that's it's almost better to learn from others sometimes. We like to joke on our farm sometimes about being the first to be second. We'll let our neighbors try that out and keep an eye on it, see how it's going. So yeah, it's a different feeling than like if you had a manufacturing plant and you could manufacture something one day and test it the next. You can have a lot of iterations or cycles, right? But when you can only study things in year increments, it's more difficult to change them. At a
So,
fast.
yeah, I've got, I guess, got about maybe 5 to 8 more minutes, and then we'll open it up to everybody else. But Mariko, I was wondering if you could just sort of put this whole conversation in context a little bit in terms of like, how much carbon can the ground hold? What is the scale of this problem? And kind of what's the role of farmers, like in your view, in solving the climate crisis?
Yeah, that is a really big question. I think that there's a lot of pretty good graphs out there for anyone who's been really looking at sort of climate change and global emissions, and sort of from a global perspective, what needs to be achieved to limit warming to 1.5 degrees. And basically what we see is that from an emission standpoint, we need to both essentially phase out our use of fossil fuels. And what most people don't realize is our current agricultural system is very fossil fuel intensive. So if for people like me who are doing inventories or greenhouse gas inventories of a crop like corn, what we'll find is that more than 50% of the greenhouse gas impact of growing that corn is fossil based, because there's embedded fossil fuels to produce the nitrogen fertilizer. There's all of the machinery that's used on farm, and there's all of the transport. So the first and foremost, what we need to do is to figure out how we're going to phase out the fossil fuels from agriculture. And part of this is going to be, we're going to need technological solutions, and part of it is going to need to be sort of reimagining what does a food system look like if we can't burn fossil fuels in order to produce our food. And then the other half of the equation is we need to rebalance our carbon cycle. So the reason we have sort of a climate crisis, a lot of people think of emissions and sequestration, but what we're really thinking about is a carbon cycle that's out of balance, because carbon is not something, it's not gold that we're trying to bury into the ground and never think about again. It's really fuel for microbes and, things that are doing amazing things in the soil. And so the goal should be to figure out how we rebalance our carbon cycle, how we ensure that we don't have more carbon entering the atmosphere than we have being drawn down into the soil. And so ultimately, farmers are going to play a really important role. But I do like to help people remember that a lot of times we think of this in a very sort of linear fashion. We want to say, how much did we emit this year? And how much, potential is there for nature to sequester and offset our carbon pollution? But a way to sort of reframe it is, a lot of people forget the 10th grade biology lessons about photosynthesis and carbon cycling, and how do we make sure that we're thinking about sort of closing that carbon loop, as opposed to just how do we put more carbon in the soil and ensure that it stays there permanently, because it's never going to be permanent.
For sure. I guess any other comments from Tiana or Brennan Clark on that? And then I just have one more question before we go to the audience.
Yeah, I'm glad to see Mariko define the problem that, there's a lot of fossil fuels used in agriculture. I'm also glad to be part of the solution. So you'll probably hear a lot in the next few years about renewable diesel, if you haven't already. The great thing, so we've been making biodiesel for a long time from soybeans. Renewable diesel is different from biodiesel in that it can be blended at any ratio with petroleum diesel. So with biodiesel, you could really only blend probably a maximum of about 20%, and not so much in the winter months because it would gel worse than petroleum diesel. But renewable diesel is chemically identical to petroleum diesel, so it doesn't have some of the drawbacks that biodiesel does. And the other exciting point probably that you may have heard a little bit about too is sustainable aviation fuel. that's a lot of it going to be made from ethanol. And that's a pretty exciting opportunity for our industry too, because that's, rather than being an extractive process where we're taking carbon from deep in the ground and burning it, we've created a cycle where we collect it in plants and then use it to power vehicles. I know everyone's really excited about electric cars, and I think they're great in situations where they make sense. Cities especially. I'd be a little bit hard pressed to replace, for example, my farm pickup with an electric car, because some days I just go back and forth to the farm and I'd be fine in an electric pickup. But then there are other on a heavy trailer and I drive a few hundred miles and it would not be suitable for that, right? I'd have to stop and charge a lot. And so, and similar with farm equipment, that's part of the reason I'm excited about the renewable diesel. Or there's companies like Clear Flame that are modifying diesel engines that burn basically just denatured alcohol, ethanol. And so those are some processes that, we can start to lessen our dependence on fossil fuels to power agriculture, right? If we can produce our own fuel, really, that's a great accomplishment. So I'm glad to be part of both the problem and the solution. So.
I think, yeah, the last thing maybe Brennan Clark, if you guys could talk about is just kind of how you guys have leveraged your Olin educations into what you do now.
Sure.
And yeah, like what does the technology on the farm look like? I mean, I know it is super high tech in many ways, but yeah.
Yeah, so I would say we use our Olin education every day. People have often asked me that question. They don't meet very many farmers that are engineers. And so they kind of usually ask with kind of a wry smile, like, well, so do you use your education anymore? And I just tell them every day, because what you learn at engineering school and especially at Olin is lifelong learning. Problem solving, critical thinking. Those are tools that you never stop using, right? And we have a lot of problems to solve every day on the farm. So yeah, problem solving, critical thinking, those are important skills. And even beyond that, I kind of joke a little bit about that, but beyond that, we run a pretty technology intensive farm. We have, auto steering tractors that we still turn them around on the ends. They have the capability to turn themselves around too. We don't always use that, but the next step beyond that is autonomy. John Deere already announced earlier this year an autonomous tractor, and I've seen prototypes. I actually saw them in person at a farm show this fall. Brennan and the kids got to go, and I pointed out to them and said, "This is a historic moment right here, because there is an autonomous spreader running, as if it's putting down fertilizer at the farm show. There's no operator in the cab." So that's really the future where we're headed, is autonomous machines, and I would say management down to the plant level. So at this point, we can get to probably, like a 30-foot level pretty easily as far as management zones. I'm certain that I shouldn't put a time scale on it. Everything's 20 years out, but I'm certain that in the coming years, we'll be able to manage down to the per plant level, applying nutrients per plant, monitoring for disease or pests per plant. We're going to have the technology to do that. And frankly, I'm excited about it. It's always been a futurist. I think most engineers are. I mean, why else would we like sci-fi, right? And so it's great. It's a great time to be in agriculture if you're an engineer, right? Because there's all these technologies coming down the pipeline. And of course, we utilize quite a few of them now that are, things like soil moisture probes underneath our center pivots, so we can monitor them. I think they report about every 15 minutes or half hour. So that's a pretty tight time scale. When the pivot only comes around once every 2 days, you're watching that and keeping an eye on it to make sure that we're applying the appropriate amount of water, not too much, that we're wasting it, or too little that we're losing yield, not being efficient that way either. So and Bryn talked a little bit about the grid sampling. Kind of when grid sampling first came out, we thought we might do it every 4 years. We've been doing it every year because the cost of the technology has come down enough that for the amount of money that we spend on fertilizer, either in the form of manure or commercial, synthetic fertilizers to keep our crops, keep the soils in condition to grow good crops. We found that it provides a lot of value, more so than what we're paying. So, technologies like that have a clear ROI, find an easy place on our farm. We're pretty big adopters.
It's also been wonderful to partner with companies and have put our input into their technologies and things coming out in the future. So that's been very exciting for us.
Awesome. So I want to open it up to the audience. Fairly small crowd here. I think I can see all of you on the gallery view. So if anyone has a question, maybe you can do the hand raise thing or just unmute and shout it out. If not, I do have more questions. We actually only got about halfway through.
Yeah, drop your questions in the chat, Sally says. Feel free to do that.
Well, I have a question. So I've been hearing a lot about regenerative agriculture as like this magical, like silver bullet that if we could just get farmers to be doing regenerative agriculture, that would like solve the climate crisis. And it seems like everybody who says that has absolutely no experience with agriculture or farming and is like in some completely different industry. So I was wondering what the people on this panel think about the way about regenerative agriculture and the way that it's been talked about. Yeah.
Sure. Well, we're unmuted on this end, so I guess we'll start. Yeah, so I think that the concept really behind regenerative ag is a lot like we were talking about in our soils discussion, that we're going to, redeem something that has been lost, right? We're going to create a better soil structure, or we're going to, solve a pest problem, those kinds of things. And honestly, I think those are admirable goals. I think the trick is kind of like sustainability. How do you define it, right? And I think regenerative ag, and I'm not an expert in the topic, but I would say the trick is how you do it, right? Because if the idea for regenerative ag is to move away from synthetics like herbicides or fertilizers, those kind of things, it has to make economic sense for farmers, because unless everyone is moving in the same direction at the same time, if you're making yourself, what do I want to say? You're creating a disadvantage for yourself, perhaps, on the economic side, then it doesn't make sense to do it. We have farm in kind of a narrow valley that's about 2 or 3 miles wide, is all, from the river trees to the hills that are not arable ground. And we farm basically beside kind of the same 5 or 6 farmers up across like probably a 15-mile stretch. And any one of them would be happy to take my job. We all wave at each other. We're all nice to each other, but it's a little bit like being professional athletes on the field. Like you might high five each other after the game, but that doesn't mean you're going to not tackle the other guy as hard as you can, when you get an opportunity. So, yeah, I would, I think it's, and I would have to admit, I'm not really an expert on what people are calling regenerative ag. Probably the biggest thing that I see that I think makes a lot of sense is particularly in food. So some of the items that could be produced locally, I'm excited to have Jake here moderating. I think his company's doing great things in that space. He didn't really give much of a bio on himself, but that is a cool idea, to be able to produce, produce specifically. I've seen some other concepts on the market, but rather than producing these thousands of miles away and then transporting them, what can we do in our cities? So that might not be everyone's idea of regenerative ag, but it makes a lot of sense to, in cases where food's involved, try and grow it closer to where people live. So
Yeah, I'd love to jump on that.
Yeah, go ahead.
Thank you, Clark. Jake, I would love to hear a little bit about freight farms. And then after that, I would love to know from any of our panelists or you, Jake, what can we as consumers do to be better, citizens of the planet in this regard? I compost, I have my little vegetable garden, but I don't know what more I could be doing to help.
Yeah, for sure. So I guess to just talk about freight farms, so we're a Boston-based company. We build turnkey hydroponic farms. So you can just go buy one. Comes in a shipping container, and you can harvest about 1,000 heads of lettuce a week. It's optimized for primarily leafy greens, different types of herbs and vegetables. And yeah, most of our customers are small business farmers, much smaller than Brennan Clark, like a lot of folks who are just getting into farming and kind of want to serve their local community, but they don't have the history, they don't have the capital, they don't have 7,000 acres of land. They're just trying to get started. We've got about 600 farms worldwide deployed. Now, the trick with hydroponics and with freight farms is that the farms we build are massively better from a water consumption standpoint. They're massively better from a land use and chemical use standpoint. They're massively worse from an energy use standpoint. So I see Ruby on the call. Ruby, I don't know if you have the stats off the top of your head, but Ruby actually did the LCA for freight farms a little while ago. And I see her here, so I don't know if she wants to be put on the spot. But
I don't have the stats off the top of my head, but I have the one-pager bookmarks that I could plop in the chat while we're chatting.
Awesome. Yeah, so out of some of the work that Ruby did actually with freight farms, we built a partnership with a renewable energy company, because if you get that energy from solar or wind, the overall carbon footprint can be better than traditional ag. But if you get it from normal high voltage coal power, it's definitely much worse. So it, like all things in this space, it ends up being pretty complicated and contextual.
So we have a question for Tiana. Is Indigo still working on using data analysis to recommend regenerative ag practices for farmers based on their specific field conditions?
Thanks. And Kyle used to work at Indigo a bit ago, so I know he has some background.
Hello.
We are, yeah. So, one of the great things about the sort of side effect of having to collect that much data to show that you're doing something different with your land is that we end up with a lot of data. So we have several agronomic tools that help farmers make choices about what changes to make, both in assessing sort of the profitability impact of a change. So as we were saying earlier, if you have to buy some new equipment and buy some seeds, but you're using less fuel and you're using less fertilizer, like how those different pieces stack up on your balance sheet at the end of the year. So we have some tools around that, and then we have some more specific, like really agronomically focused tools. We have a lot of agronomic experts in the building, which I'm certainly not, but they can, we have some tools, and some of these are available like right on the website. You don't even have to be participating. You can explore like, well, what is the right cover crop for your situation? Are you dealing with compaction? Are you dealing with low moisture? Do you, what kind of crops are you growing? That sort of thing. And it can suggest like, oh, well, hairy vetch would be a good, good crop for you, or a blend of these 3 or 4 things. So we really try to use some of that, that expertise and that large data asset, to help folks make that jump, make that transition, because it can be a hard one. So anything that we can do, and honestly, a lot of farmers don't want to take advice from a technology company in Boston. They would rather, talk to their neighbors and learn from, the folks in their industry. But to the extent that we pull in, advice from people deeply, steeped in agriculture, we try to at least make those tools available and make it, some side benefits of having all your data smushed into one place.
Thank you. Good to see you.
There's a question for Brennan Clark from Olin Hydro. I'm curious if you feel there are any areas within your practice that you don't feel is getting enough engineering attention and development.
That's a good question. I would say it's kind of open season, right? I mean, there are opportunities for improvement everywhere. Probably the most exciting thing to me in terms of engineering development would be technologies that can directly impact our production. So, and some of the limited resources we have, we're limited on labor. Is probably the hardest one, finding qualified people to work on the farm. And so there are some concepts out there, with autonomous vehicles. I think any of those autonomous vehicles have to be informed by a lot of different sensors. That's probably going to be a big thing in agriculture here in the near term, is developing sensors that tell us what we need to know out in the field, whether it's sensing plant health or soil moisture, nutrient content, just all those things. I became aware of a company recently that has bred a gene into soybeans that they will phosphoresce. They will glow when they're when they're introduced to stress. So that could be a useful tool, right? Some nighttime imagery of the field that would show you exactly the areas that you need to go scout. There's a lot of imaging technologies that try to do things like that with NDVI, those kind of things. But as far as things that aren't getting enough attention, honestly, there's quite a bit of ag's had kind of a pretty big chunk of money. VC funds, et cetera, seem to be pretty interested in what's happening in ag. We have a challenge ahead of us, right, to feed the world. And some of the tools that we've been given, I feel like we've gone about as far as we can, right? We're going to have to find some new tools. And I actually just saw the question come through in the chat about whether GMO foods are good or bad. In my opinion, as a farmer, I would say they're good. And the reason I say that is, for example, like the BT traded corn has reduced pesticide usage. I think it's like 90 or 95%. And, from my perspective, where they're inserting a protein, the capability to make a protein into a plant, in a insect gut, that's harmful to the insect, right? But in a mammalian gut, it's just another protein. So that'd be a good example of like a real home run GMO trait that exists in the corn market. There's, I kind of feel like, because we all know that pesticides are harmful to humans, right? There's pretty good documentation of that. You don't want to be exposed to pesticides in general. Whereas, just a simple protein would be much preferable method for me as a farmer, and I think also as a consumer, because I can see both sides of that plate, right? So I'm a big proponent of GMO. The other reason I would say I'm a proponent of GMO is it enables us to increase output. As long as there are hungry people to feed in the world, we need to increase output, right? As long as there's cars that need to be fueled, as long as there's all animals that need to be fed, those kind of things. That's the right thing to do, is to use all the tools at our disposal. So a lot of people are pretty excited about organic foods. for example. And that's probably the next question right after GMO is organic. The tricky thing about organic is that really what we're doing is taking a step back about 70 or 75 years in production methods, at least, probably in some cases more than that. And we're burning a lot more diesel to do it. It requires a lot more passes through the fields to do weed control, for example. So there's always trade-offs to every system. You might be using less pesticides, or fewer pesticides, but you are using a lot more manpower, a lot more equipment, a lot more fuel in order to keep weeds down. So there's always kind of a sliding scale, right? There's seldom a black and white choice. It's always there's always some gray in there of which way is better. So.
Can I jump in for a second and ask Jonas or Malvina or Dokyun, can you talk about Olin Hydro? This is a club that our alumni, I think, are not familiar with. Love to hear what you are all up to.
Yeah, sure. Hello, good to be here. We're actually in the space right now. We are working on building an automated hydroponics green wall on campus that would serve as a community garden for students and the general Olin community. That's us in a nutshell. I don't know, anything to add, Malvina?
Yeah, so hydroponics as a club is part of public interest technology, which is a project team. So we're trying to explore hydroponics as a technology, but also in the context of the public interest, sustainability, food justice, and seeing if hydroponics can play a role in those fields.
Yeah, thanks. Super interesting to hear everything here. Really helpful for forming our perspectives.
So I saw Carrie's comment in the chat as well around sort of the other structures around GMO. And I think my comment on that would be GMO is like many things, it is technology, and the context in which it's used is definitely a really important part. It's like, GPS is an amazing technology that's enabled a ton of things. It also enables GPS guided munitions, right? So is it good or bad? I think personally, GMO is not all that much different from selective breeding that we've done for a really long time. It's just an accelerated way of doing it. But if you have companies where the structures are not really benefiting the farmers, or you have to sort of lock into a seed that you have to buy every year, things like that, it does get more complicated.
Yeah,
Sure.
correct me if I'm wrong, but I think the biggest producers of a lot of these GMO crops that are being sold and planted by a lot of farmers are also selling the pesticides for which these crops are resistant. So I'm thinking like Monsanto. And then using the pesticides means that you have to use the seeds that are sold by the company, and it's kind of a cycle. And then there's, in terms of like ownership and seed saving, like going after farmers whose seed has been cross-pollinated by another farmer's seed that they didn't have control over, and then like lawsuits that have come from that and stuff. I think it's not black and white.
Sure. Yeah, some good points. You're right about companies often selling the technology, right, in the crop, and also selling the herbicide, for example. The good thing is that many of, just like in the pharmaceutical industry, eventually, the patents expire on the chemistries that we're using to control weeds, for example. And some of the technologies that exist now, you don't have to buy the herbicide through the company that originally, like glyphosate would be a good example. We're all familiar with all the litigation surrounding glyphosate. Monsanto developed glyphosate, but there are, oh gosh, I can think of probably at least 20 companies that manufacture it now. So that drives competition in the marketplace, right? When you have lots of companies that can, that can manufacture the same product. As far as the traits that go into like herbicide resistance traits in crops, typically those get licensed out to a whole bunch of different companies. Like I'm trying to think of a good analog, but it would be maybe a little bit like a software company developing a piece of software and then selling it to a whole bunch of companies that want to use that piece. That happens within the seed industry as well. So there's probably less lock-in than might be apparent from the outside. For example, there's the Enlist bean technology, soybean technology. There are probably like 6 different brands of seed that I can buy in my area, at least, probably more, probably 6 that I do buy. Maybe there might be 10 or 12 that all can utilize that technology. So, there's more competition within the landscape maybe than it might first appear. And as far as people have talked about saving seed, for example, how GMO traits, really you are abiding by a license agreement when you buy GMO seed. But it's been that way for a long time, really since the advent of hybrid in corn specifically. Since the advent of hybrid corn in, I believe it was the 50s or early 60s, we haven't been able to save seed because that wouldn't be a hybrid cross where you take a male line and a female line and you pollinate them together in order to make that hybrid. The seed that you grow is still GMO, but it is not a hybrid anymore because it's not hasn't been a hybrid cross. So productivity on that seed is going to be a lot lower in the case of corn, just because of the way hybrid genetics work. So really it's in our interest, I would say generally to plant hybrid corn, for example. That's been a technology that's been around for in the neighborhood of 70 years. So there are other crops where you can save seed. Wheat's a good example. There's a lot of people that save seed for wheat, and you can take your choice there, whether you'd like to or not. So I think sometimes the issue gets sensationalized a little bit by the media, as far as that companies are being predatory towards farmers. In reality, I think there's a lot more competition amongst all the different companies that offer seed, for example, that helps keep prices. It's a free market system as far as that goes, that I can choose to plant any company's seed that deals seed in my area. So. If there was any other questions in the chat or not, I thought maybe we saw a couple pop in.
There were a few people just dropping off.
Okay.
Yeah, and thank you, Ruby, for dropping that infographic there.
Sure.
I feel like I could probably talk to this crew for a very long time, but it's also coming up on 9:20 here. I want to be conscious of everyone's time. Sally, I don't know. If we have more questions from the group, we can definitely take them for a few minutes at least.
Yeah, I would agree. Otherwise, we can.
I have just a question based on the comments I put in the chat. Would current students and alumni be interested in us forming kind of an ad hoc agricultural Olin Ag club group e-list? I'm not sure what the purpose of it would be, but it seems I'm so impressed just how much interest our current students have in agriculture. We had a fall gathering day the other Friday, and some students went to a local farm. They're volunteering at community farms. We had the farm project, the off-grid sustainable farm, Sally, that happened during the pandemic, where we had a group of 10 students go down there and stay for a semester. And it just seems like there's some strong interest, and our alumni are doing some amazing things in ag tech, ag adjacent things. So maybe we should get something going.
Yeah, we'd be happy to be a part of that. That'd be fun. And yeah, always happy to field questions. I feel like we talk about that a lot in agriculture, that we're kind of busy on the farm, and sometimes we forget to tell our story about what great things are happening, and just the wins that we see out here that don't necessarily always transmit to directly to the grocery store shelf. So it's yeah, I'd be happy to take part in that. That sounds fun.
Yeah, likewise, happy to.
Anybody else?
I think there was the one last bit that you had wanted us to touch on of how can folks get involved, like.
Oh, right.
Certainly, becoming a farmer takes a certain set of skills and assets and capital and stuff, as I'm sure Clark and Mariko can speak to. But in the sort of rest of the tech supporting ag space, we've got software engineers, product managers, designers, operations folks, a lot of data analytics, all sorts of more typical, post Olin pursuits at Indigo and at some other places similar. So, if that's something that you're interested in, you don't need to have ag experience to make a path in the ag adjacent tech space anyway. And if you're looking, hit me up. I'm always happy to talk and connect folks and find the right roles.
Same here. I'd also add that I never worked in ag before I worked at Freight Farms. I worked in a lot of technologies that Freight Farms uses. And then when I came to Freight Farms, I started learning about plants, and I've learned a ton about plants in a few years. But yeah, you can just get started in those skills that you get at Olin and just in engineering in general will definitely transfer.
Yeah. We passed around a funny graphic amongst a group chat, just a text group that gardening is the gateway to farming. Like it's the parent having a conversation with their teenager. And so yeah, definitely keep gardening. And I think that I don't garden much, obviously, when I get home from the farm, but
Shocking.
That's a great way to understand some of the challenges. Or you could watch Jeremy Clarkson's Farm on Amazon Prime. That's a pretty good one. I feel like most reality TV shows, they drum up like, oh, we broke this thing and we're never going to be able to financially recover and all that. And the stuff that happens on Clarkson's Farm is 100% real. Like it really would actually happen. Like they are not joking. So I don't know. He does more animal agriculture in his show than we do, but and kind of on a little bit different scale than we do it on our farm, but the challenges are the same, right? He deals with weather, and as far as, there are a lot of opportunities in industries that are tangential to ag, everything from meteorology to commodities trading to even the guy that works at the local tire shop that comes out and services my ag equipment when we have a 8 foot tall tire fail. There's so many, to the seed companies that develop the technology that we use, people like Tiana and Mariko and Jake, obviously, that are in a lot the tech space or carbon credit space. And there's lots and lots of opportunities in ag. You could even come work on farm if you like farming. So
there are lots of farmers putting ads out for help that would like some qualified help.
Absolutely.
Well, we'll certainly have students looking for summer opportunities. So if you have an opportunity and can
Send them out to Nebraska.
Yeah.
Absolutely. Absolutely.
Mariko, do you have any parting words for us?
Nuance. I think one thing I find is typically missing anytime we're talking about farming is that the type of farming that Brennan Clark are doing and the type of farming that Freight Farms is doing, like they're different things. We're not going to grow corn hydroponically in containers. We're not going to grow lettuce on 7,000 acres. And then the type of farming that Kari is doing is also the diversified kind of fruit and vegetable farming, very, very different. So if anyone's interested in agriculture and talking about it and understanding it, yeah, make sure you're understanding the nuance that's associated with the different things that we grow and the different things that people eat. Because it's very easy to say, oh, this is a one size fits all approach, but things are very different depending on what you're trying to grow and what region you're growing and how labor intensive it is, how capital intensive it is, et cetera, et cetera. So do your homework.
Great, thanks. All right. Thanks, everyone. Wow, what a fantastic panel. And thank you, everyone, for joining us. I don't know what else to say. It's all been said. Brennan Clark, wonderful to see you. Mariko, thank you. Tiana, Jake, great job moderating. And thanks to my team, Jess and Kristen. It's been great. Wonderful evening. Thanks, everyone. Bye.
Thanks, everyone.
Thank you
Thanks
for
all.
raising. I appreciate it.